Hello, ladies and gentlemen. Today we're going to talk about reflections. You're going to need your notes that I gave to you in class, a pen or a pencil, something to write with, and possibly a calculator. So in our first example of a reflection, we have this little shape, S, R, P, and Q. I'm going to outline it in purple maybe so we can see it a little better. Okay, so we have this point, and now we need to talk about reflecting it. Remember, reflection is just a mirrored image. So another word we used was flip, or the line we underlined was flip. Okay, so now let's talk about if I need to go over the x-axis. Okay, so I'm starting with the point P. If we look at the point P, the coordinates of point P are -2, +3. So I'm going to write that in here for -2, and I went up 3. Okay, Q then is, actually let's start with P here. If I take P and I go over the x-axis, since the x-axis is my horizontal axis, right here, if I take P, it's 3 up from the x-axis, so now I need to go 3 down from the x-axis. And I would label this P prime. Okay, so now I'm going to plot that coordinate point. So that is still at -2, but now it's at -3 on the y-axis. So let's jump to the point Q. Q is the point -2, 1. Okay, if I take Q and I flip it right over the axis, since it's one above the x-axis, I need to go one below the x-axis and label that Q prime. So when I take those coordinate points, I get a -2, -1. Okay, R is my next point. R is the point -3, 1. Okay, and again, since it's one above the x-axis, I need to go one below the x-axis and label that R prime. And the point R prime then is -3, -1. And our last point we need to do is S, and S is the point -3, 5. It's 5 on that y coordinate. So then I need, since it's 5 above the x-axis, when I flip it over, it needs to be 5 below the x-axis. It's a mirrored image. So that would be S prime, and then I can connect all of my points. And it should look like a mirror image across flipping it over that x-axis. But again, if we write that S prime point, it's -3, -5. Okay, so when we compare this, how did point P change when it became P prime? The numbers look very, very similar, but if you notice, in the first part, my y was positive, but in the second point, my prime point, my image, it became negative, and my x value stayed the same. So when we flip over that x-axis, our rule that we need to take note of, going down here, writing it in the box, is the x stays the same, so it's still going to be x, but the y changes its sign. So the rule we follow is x, opposite y, or -y. So now let's talk about what happens if I flip over the y-axis. So I'm going to highlight, we're still dealing with the original, the pre-image. Okay, so we can steal all the points. We know P is -2, 3. We know Q is -2, 1. We know R is -3, 1. And I'm just pulling these from the points right here, stealing those same points. S is -3, 5. Okay, so now I want to go over the y-axis. So that means I'm going over this y-axis right here. I need to flip it. So looking at P, since P is 2 away from this line, I need to go on the other side of the line 2 away. Okay, since I already have a P prime on my graph, I'm going to label this P double prime. So then this new point is +2 and +3. Sorry. Okay, next thing, Q. Again, it's 2 away from my y-axis on the left, so I want to go 2 away on the right and label it Q double prime. So those new coordinates become 2, 1. If I take R, since R is 3 to the left of my vertical line, my y-axis. I need to go 3 to the right and get r double prime. Oops, it only looks like I got 1 prime in there. Double prime. So then those new coordinates become 3, 1. And S is, again, 3 away from this vertical line or my y-axis, so I need to go 3 to the right and label that S double prime. Connecting my points. Okay, to get that, if you can tell, it's a flip, it's a mirror image across that y-axis now, and my last S double prime is 3, 5. Okay, now when we compare these, if you notice, we'll just talk about the S value. My X value is -3 in my pre-image, and in my image it's a +3, but my Y's stayed the same. So the rule is opposite X when Y stays the same. So now as you can imagine, if we did both, we're going to negate both of what we started with. Because when we just do one, that means we negate, when we did the x-axis, we negated the y. When we flipped over the y-axis, we negated the x. So if we do both, that means they're both going to have to be negated or opposite. So let's move on to another example here. We're going to reflect triangle JKL over the x-axis. So I need to go over this horizontal axis because this is my x-axis. Okay, so what I want you to start with is I want you to start by writing down your points. Okay, J is 1, 3. L is 1, -2. And K is 3, -2. Okay, so now the rule when I'm going over the x-axis, that means I'm negating my y, and x is going to stay the same. So if I think about this before I even flip it, before I even take this and talk about it on a graph, I'm going to negate it to j prime by x is going to stay the same, remember, so I'm still going to keep the 1, but I'm going to negate the y and make it opposite. So this is going to become a -3. When I do this to L prime, I keep my x value and I negate my y value. So since my y value is a negative, it's going to become a +2. And lastly, when I do K prime, I keep my x value of 3 and I negate my y value or change the sign, which would then make that a +2. Now I'm going to go and I'm going to plot these points. So J prime is 1, -3. When you plot it, make sure that you label it J prime. L prime is 1, 2. Make sure you label that L prime. And K is 3, 2. Label that K prime. Connect your points to make the triangle. It should just be flipped about that x-axis. We took it and we flipped it over that horizontal x-axis. So our next example is similar to the last one, except now instead of switching over the x-axis, we're going to switch over the y-axis. So the rule, since I'm switching over the x-axis, is I'm going to take the opposite of x and leave my y the same. Okay, so then let's pull these points. A is the point, we're going 1, 2, 3, 4, 5 to the left, and we're going down 6. Okay, B is the point, -3, -2. C is the point, -1, -6. Okay, so now my rule to get A prime, I have to negate or take the opposite x, so opposite of a -5 would be a +5, and I leave the y as is. Same thing with B prime. I need to take the opposite of x, so an opposite of a -3 is a +3, but I still keep that y value. And to get C prime, take opposite of x, which gives me a +1, keep the y value. And then I go and I plot these points. So A is the point 5, -6, labeling that A prime. B, 3, -2, labeling that B prime. And C is 1, -6, labeling that C prime. So when you connect your dots, again, this should be a mirrored image over the y-axis, which is the vertical axis. In the next example, it has my pre-image drawn for me, and we know this is the pre-image because it's the image before I translate it or reflect it. And I know that my prime image is always my image, the product after I did my transformation. So we need to describe the reflection that's happening to RQS. Okay, so first off, if I get the point S is -2, +1. Okay, when I go to the point S prime, if we think about the point S prime, we're at a +2, -1. Okay, then let's go to R. If I do R, we get a -2, +5, and R prime is a +2, -5, and Q is the point -5, +2, whereas Q prime is the point +5, -2. So when we compare these points, how does this point Q relate to Q prime? How does -5 relate to 5? Looks like it's the opposite X. How does +2 relate to a -2? Looks like it's the opposite Y. So if this is what's happening, we know that we are reflecting over this rule. If you check the front page of your notes again, both X and Y axes. Okay, make sure you get that written down. This next example is a little tricky in being that it's not over a necessarily straight line. I need to think of the line y equals x. So this goes back to when we're graphing equations. This is in slope-intercept form, y equals mx plus b. Okay, so now when I have just the equation y equals x, that m value that's hidden there is 1, and my b value that I don't include is 0. So I start at that 0, and my slope is up 1 over 1, up 1 over 1, up 1 over 1. So I got to start by adding in this line that I need to reflect over, because it's not the x-axis, it's not the y-axis, this line that I have to draw in. Let's see how straight I can make this. Ooh, not too bad. Okay, so now we need to reflect over this. Okay, remember, reflecting is just an image, so there's no trick with my points here, A and B and C. Okay, we have to strictly just use our knowledge and reflect, make it that mirror image. So we're going to talk about the diagonal distance. So now instead of counting the boxes, we're going to count the diagonal boxes. So if you look at our point A, we want to count this box is 1, that diagonal. Here's my second diagonal, third diagonal. Okay, but this one I don't get a full diagonal, so that's just a half. So I had 1, 2, 3, and 0.5. So that means when I go to the other side, I need to have half a diagonal. Here, I'll change colors for this. I need to have half a diagonal, which is good. Got rid of my half. Now I need to have 1, 2, 3. And this is where A prime would go. 1, 2, 3, with a 0.5 here. So again, we're counting that diagonal distance. So let's do B. I count from B, the diagonal, we get 1, 2, 3 whole diagonals. So that means when I reflect it across this line, I get 1, 2, 3 whole diagonals, put my point and mark it as B prime. So lastly, let's look at the C. C is about half a diagonal away. So then when I go to the other side of my line, I go half a diagonal. I plot that point right there and label it C prime. So once I have all 3 points, I can connect the points, and hopefully my image looks like a flip of my pre-image. So in the last example we have, our line now is again slightly different. The line is x equals 2, or -2, excuse me. So I need to figure out how to draw a line where all of my x values are -2. Well, first, my x-intercept at -2 would be right here. So where else on this graph could I draw a point that would have the x value of -2? Any of the points above the point I just graphed would have a value of x equals -2. This is the point that would be -2, +7. So if I were to write that in, it'd be 2, 7. Excuse me, -2. So that's again a point. So when I connect these two dots, we should notice that the line x equals 2 is a vertical line through x equals -2. Okay, so again, now I'm going to reflect this shape ABC over the line x equals 2, or -2, excuse me, wow. Okay, so let's count. This point A is 1, 2, 3, 4, 5, 6, 7 boxes away from my point, or my line of reflection. So if it's 7 to the right, I need to count 7 to the left. 1, 2, 3, 4, 5, 6, 7. And again, we label that A prime. Okay, if we do B next, B is 1, 2, 3, 4, 5, 6, 7, 8 to the right. So then I need to shift it to the left of the line 8 units. 1, 2, 3, 4, 5, 6, 7, 8 right on the edge of my graph there, labeling that B prime. And C is 1, 2, 3, 4 to the right of the line. That means I need to go 4 to the left and label that C prime. So once I get all those points in there, we draw that picture and hopefully it looks like a mirror image. So I want to thank you for taking good notes. I will see you in class. And if you say the word chicken, if you whisper the word chicken when you get to class, I will give you a bonus point for watching your video.